Howdy, everybody. Hope you're doing okay wherever, or you're doing well wherever, whenever you are. Um, so just as a quick catch up, I actually was recording this video and then had an interruption. So I'll catch up to where I'm at. I haven't actually done any coding. I was just thinking about the solution. So anyway, I'll reread it and then we'll get to the solution if that's okay with you. So today is Dragon Checksum. You're done scanning this part of the network, but you've left traces of your presence. You need to overwrite some disks with random looking data to cover your tracks and update the local security system with a new checksum for those disks. For the data to not be suspicious, it needs to have certain properties. Purely random data will be detected as tampering. To generate appropriate random data, you'll need to use a modified dragon curve. Start with an appropriate initial state, your puzzle input. Then, so long as you don't have enough data yet to fill the disk, repeat the following steps. Call the data you have at this point A. Make a copy of A, copy it to B. Make a copy of A, call it B. Reverse the order of the characters in B. And then in B, replace the zeros with ones and the ones with zeros. The resulting data is A, then a single zero, then B. For example, after a single step of this process, 1 becomes 100, 0 becomes 001, and then a couple more examples. But hopefully you get the idea. It's like, take A, make a copy of it, reverse it, and swap the ones and zeros to get things like this. Repeat those steps until you have enough data to fill the desired disk. Once the data has been generated, you also need to create a checksum of that data. Calculate the checksum only for the data that fits in the disk, even if you generated more data than that in the previous steps. So that part is the, if you generate 100 characters, but you only need 80, truncate it to 80, right? The checksum for the given data is created by considering each non-overlapping pair of characters in the input data. If the two characters match 00 or 11, the next checksum character is a 1. If the characters do not match 01 or 10, the next checksum character is a 0. So this is like, I was trying to think about it. I think this is like the equivalent of a not XOR. I don't know. There might be a term for like NEXOR or XNOR or something like that. Anyway, that's what it's telling you to do. This should produce a new string, which is exactly half as long as the original. If the length of the checksum is even, repeat the process until you end up with a checksum at odd length. So you're going to keep doing this, like getting pairs or chunks and doing these XNOR on them until you get an odd length. So they give you an example. If you have this, it creates these pairs, and those pairs, right, you XNOR them or whatever, not XOR, ends up giving you these, right? Because this is 1 1 0 1 0 1. The resulting string has length 6, which is even. So you do it one more time, and eventually you come to 100. So it says the checksum of this is 100. And then it gives you kind of a full example. Say you wanted a length of 20, and your initial state is this. You'd have to do the dragon curve twice to get this much data. But then you only keep 20 characters of it to give you this. And then you do the checksum loop. You have to do it twice to get to 5 characters, because you'll go from 20 to 10 to 5. And then it says, in this example, the correct checksum would therefore be 0 1 1 0 0. The first disk you have to fill is length 272 using the initial state in your puzzle input. What is the correct checksum? And then this is my puzzle input. Okay, so what I was thinking of is 272 is relatively small. So it feels like you could just run, you just run this maybe like, no more than, I don't know, 7, 8 times, 10 maybe at tops to get the thing. And then you'd run the checksum because it's 272. I don't know. It halves each time, so you get somewhere on the order of like, I don't know, 5 or 6 times to get to an odd checksum. Actually, you may only have to do it. No, you will have to do it a few times. But anyway, it won't take too long. So you could just literally do this, like have a string perform this operation and do this. But where I left off and was interrupted and had to stop the video was I was wondering if there's like a math way to do this. And let's see, where was I? Oh, right. I was let's see, you might be able to determine the number or what a character is in the final output by doing some doing like a kind of like a recursive search for that specific character in like log n it'd be log, I think I said it was log k when I was thinking about it. Imagine this, the length is k, it'd be like log k time. You'd say, okay, I have this or where was it? So let's say I have this string. I can kind of derive that whatever character I was getting, maybe it comes from this bit right here. And then I just have to figure out how many times it rotates and flips around. I think you actually have to work backwards though. So you presume you have 272 characters and you want the third one of it. You know, when it's flipped and rotated, that it will become like when it's flipped and rotated, it now becomes like the, I don't know, 180th character. And then flipped and rotated, it becomes like, well, 180 wouldn't be right. It'd be like the 130th character. And then you flip and rotate, and then it becomes like the 15th character. You flip and rotate, and it becomes the 40th character. You flip and rotate, and it becomes the 5th character. And so then you get here and you now know it's 1, 2, 3, 4, 5. So you know it's like this one is where it comes from. And like, because you've done it that way, you now know that it should be a 1. I think you could do something like that. Could you do something mathematically with the checksum? That's a really high level thing. I'd have to think that through to say if you could implement it, but my inkling is you could do something like that. The idea is like, given this string and some value k, you can probably figure out what the nth bit is in like log k time would be my guess. Something like that. And then this one, the checksum part of it, should we think about that for a minute? We can definitely, because it's 272, we can definitely figure out how many times we need to do the checksum, right? Like you go 272 divided by 2. Then you do 136 divided by 2 and 63. Now you're done, right? So I think you just keep dividing by 2 until you find an odd. So you need to do the checksum, at least for this one, twice. What is the checksum? I mean, it's definitely an X, a not XOR. Should I just look that up? I mean, it's definitely a thing. Pronounced as exclusive NOR. X NOR gate. Yeah, this is exactly what we want, right? Double zeros is 1, double ones is 0, alternating. Sorry, double ones is 1, double zeros is 1, alternating is zeros. So that's definitely what we're trying to do. Is there any interesting math of like X noring X nors? The thing that's going through my mind is like XOR gates are really cool because they're like reversible and stuff like that. And so you can often do like interesting math with them that you can't do with like other gates. And so because this is essentially like an XOR gate, but knotting it, I think you can do things like I almost want to do it by hand. One, two is 0, 0, 1, 0. It's like A plus B plus 1 mod 2. A plus B plus 1 mod 2. Yeah. Yeah. It's A plus B plus 1 mod 2. Does that help us any? Oh, it's probably even simpler. It's just if there's an odd number of ones. And it is, this is where the XOR part helps, I think, because what it means is I think it may mean that the checksums are not cumulative. How do I describe this? The checksum of this value is equivalent to the checksum of like this value and this value. Like, so we have a length of 12. We have this section right here. This is a length of 12. We know we need to checksum it twice, so we need to split it in half. Yeah. Here's what it is. I think you can actually do the checksum in a single pass. Like, say you know this is the digit. I'll check this again. This may be a weird path I'm going down. It may not be worth it, but I don't know why I'm feeling so mathy. We know we have to do this twice. And so the end value is 3. So we know we need to get 3 digits of checksums out of this string. So we break this string into 3 parts. So we get 4 chunks. And because of like the chaining property of XORs, I think we can just like XNOR this whole thing kind of like one at a time. Add another one, do no. What did I say? We just need to know if it's even or odd. We just need to know if there's an even or odd number of, like, these have even, this has even, this have even ones. So like we take this 4, these are even, so that's a 1. We take these 4, there's an odd, so that's a 0. We take these 4, that's an odd, so that's a 0. I mean, I think we can, I think that's right. So let's try this one. This is a much larger one right here, but we need to do the checksum twice. So we need to, we're going to get the length of 20 divided by 2 divided by 2, which is 5. So we need to break it into 5. And so we want to take 4. So no. So 0, 1, 1, 0, 0. Does that make sense? I think that makes sense. Okay. We still have to generate the string, though. I don't know how to do this calculate nth. I don't think it matters for this size. We'll see if it matters for part 2. Like my thinking is like for 272, we can just create the string and then we can do our shortcut for the checksum, right? Doesn't help us a ton, but we can still do the shortcut for the checksum. I mean, maybe we'll just do the regular way and then we can shortcut the checksum and the thing. But then what if the next one is 5 billion, right? I can't make like a 5 billion length string. I mean, maybe I can. I don't know. Okay, let's just start coding. We're just going to get a string. Easy enough. So what do we do? This dragon curve. What do we call this? A stir string. And so what is this? There might be like a string builder that we could use to, anyway, we'll worry about that later. There might be optimizations to do a string builder. So it's format A0 B, and B is isn't there a reverse? Oh, I need to do a.cars.reverse .map C if C equals 0. We return 1, else 0 dot collect. Like that. Oh, it doesn't let me. And you do this like n times. While a dot len is less than n. Like that. So like that. Oh, and I return a. Like that. I only want to return the whole thing. checksum of a, so give me a stir, and I'll give you a string. So the checksum of a is well, I always need to do it once. So let's C equal a dot cars dot chunks. Return an interval that can chunk. No, 2. If they're the same, we return 1, else 0. And then we do while c dot lane dot is power of 2. No, is multiple of 2. While it's, yeah, while it is a multiple of 2, we want to do this again. Like that. Something like here. Iter tools. Okay. Into chunks doesn't satisfy iterator. So this chunks returns an iterable that can chunk the iterator, yields sub-iterators, chunks that each yield a fixed number of iterators determined by size. Oh, is there a tuple chunks? Sorry, I'm over here just... let's see. Chunk by chunks. Yeah, see, I don't want windows. I want actual chunks. I can just do it myself, but it would be fun to find an iterable way to do it. I could do as bytes. Okay. That seemed to have done something. So how about solving it now? So we say dragon curve input 272. What am I returning? That? I mean, it returns really fast. Like I said, maybe it's not a big deal. Too low. What does that even mean? A0B. It wants me to reverse it, right? I just need to double check I'm not doing anything wrong. A, make a copy of A, call this B, reverse B, cares, rev, map, collect. Switch the zeros to ones and the ones to zeros. LOREM. Take chunks of 2. If C0 equals C1, return 1. If they're the same, return 1, otherwise return 0. While the length is a multiple of 2, do it over and over and over. Okay, should we try it with another input? We know this one with 20. 0, 1, 1, 0, 0. Hmm. What did was I doing this wrong? 272 divided by 2. The checksum is going to have in size x time 136 divided by 2. 68. 68 divided by 2. 34 divided by 2. 17. Let's see. If the two characters match, it's a 1. If they don't, it's a 0. Feels like I'm doing stuff right. Why would it work on the sample input but not the larger one? Do I get a different value if I do like yo, that is a different value. Is my input messed up? Day 16.text. Oh, it is. Oh, man. I need to trim. Boy, oh boy. I forgot to trim. I forgot to trim. I should probably add that as the. Okay, it's right. I should probably add that to my template I use. The second disk you have to fill has length 335 million. Okay. I mean, there's a chance I can still solve it this way. No. Yeah, it only takes 142 milliseconds. That's right. I wonder if, like, I mean, 142 milliseconds isn't fast. Okay, well, not too bad. Had a couple bugs I had to fix. I spent a lot of time thinking about part. I spent a lot of time thinking about part, just like if there's a mathematical solution, which turned out to like totally be unnecessary, right? I guess I don't need iter tools anymore. Yeah, I think you can use a string builder. Let's see if Rust has a string builder and if it speeds it up. You know, there's things that are like stringies. Push stir, push. So you can just do a dot push. I don't know how much that helps. It looked like it shaved off like a few milliseconds, not a lot. Is there something like if I know the actual size so it doesn't have to do a bunch of allocs with capacity? So you could do something like, technically you could say like let L equal L equal A, and then while A less than N, A equals A times 2. So it'd be A times equals 2 plus 1. And that helps like a very, very little bit. It's like weaseling it down just a little bit at a time. I still have the same numbers, right? I mean, it's going to be hard to 100. Looks right. Yeah. You only do it 3 times here, but you do it 20 here. Okay, so this one might be a candidate for the math one. I'm pretty sure you can figure out the math. Let's just see if we can do it. We can say like that's interesting. They both reduced to 17. I wonder if there's something special about the puzzle input. Okay, so what was it that we figured out? That we know this end one is 5. So we break this into chunks of 5. Is that right? No, chunks of 20 divided by 5. Chunks of 4. 1, 2, 3, 4. Gives us 0. 1, 2, 3, 4. Yeah, chunks of 4. So it's like let chunks equals a dot len divided by n. So I don't actually care about the count. For some reason I thought it was a count. Well, I had to do it n times, so I end up with 5. I know I'm going to end up with 5, and so I need to break this into n. 20 divided by 5, which is 4. A len divided by n. And then I can do c dot as bytes dot chunks dot map c dot iter dot filter c equals 1 dot count dot is multiple of 2. It's like if this, we return a 1, else 0. I need to. I think I can do it right here, right? It's actually right here where you're supposed to do it. Okay, that is significantly faster. Do I still get the same answer? Okay. Okay, that feels good. That did optimize it. That like halved the time. My computer's probably mad that I tried to allocate 35 meg. I mean, that's actually relatively small. It probably makes a difference for really large. Yeah, it would be interesting. Again, I think you might be able to, and I don't want to do this. I feel like I'm done with this problem. Yeah, we've been going for a little while, right? I think you might be able to derive the nth character. You have to do that 35 million times though. Like, is that actually going to be faster? So why am I saying that is because like, and maybe it won't be faster. If you didn't have enough memory, you could probably derive the nth character without like actually creating the string. Again, because I think, I don't know, if it was 1984 and I got my first computer or whatever, this would be infeasible, right? There's no way I could do this. But I could write a program that would, I think, if I spent enough time doing it, that could like figure out what the nth character is in the final output. Because if you think about what you're doing is you're taking this like this character and this character comes from this character and this character comes from the reverse of this character, and this character is like the partition and it's always 0 in it from this one to this one, which means you can derive you can kind of follow that algorithm. I think doing some doing that algorithm over and over again, and you just have to do it again like log k times, right? Because you're always doubling it, and in this case you'd be so you'd be doubling it and you'd be figuring out like, okay, well, where is it? You know, the character starts here, but then it becomes here the first round, then it becomes like this one. This is not a good example. Where can I find one where it actually does it? So this character becomes this character in this iteration. Well, what should I say? This character is associated with this character and this character, right? So if I had stopped and I was looking for the 0th character or the 11th character, I could do the math and say, oh, that those two come from this character. That makes sense. And so you can kind of, I think you might be able to do something along those lines. I'll have to think about it. Anyway, maybe you know a better way to do it. Maybe you've you've been yelling at your screen saying, here's how you do it, post in the comments, right? I'd love to see how to do it that way. That would be really interesting to know if there's a way to do that. But this will definitely be one that maybe I come back to as well. We found a couple in these last days that I think are worth reevaluating. The reason is because I think I understand. So the previous one was an actual algorithm from CP algorithms that I remembered was a thing. I think those are worth looking at and knowing when you're trying to solve these problems. Just knowing all the different, like, quote unquote algorithms you might stumble upon is definitely helpful. This one I think is a mathy-ish problem that there might be some way to like algorithmically figure it out, and it might be worth knowing how to do something like that just because it gives you like the reps of saying like, hey, how do I take certain, how do I like derive values from a given input. I don't know, maybe you don't need to do that. These times are, I mean, they seem pretty good, right? I actually think I did okay on this day looking at these numbers, right? This is harder to see, I realize. I'm sorry. Reading the problem was 4 minutes. Part 1 was 35. I think a lot of that was me thinking about the math, though. I hope. Because I don't think oh, I did have a bug. Right? So I did have to fix a bug. Man, remembering all the changes and stuff and fixing the bugs, I think is important. What was I forgot to trim. I'm going to add that to my default so I don't forget, because I think I've fallen for that a couple times. Okay. Anyway, there you go. Hope you all had fun watching. Let me know how you did. I'll upload my solution and we can share them and work together. Just keep improving, getting better. Thanks, everybody. Bye.